Hidden beneath our Pacific Ocean lies a chasm so extreme and hostile that it makes outer space seem welcoming by comparison. Right now, as you sit comfortably watching this, there exists a place on our own planet where the conditions are more brutal than anything humans have encountered in space exploration. We're talking about an environment so crushing, so dark, and so chemically hostile that it challenges every assumption we have about where life can exist. Most people know the Mariana Trench as simply the deepest spot in our oceans. But that description barely scratches the surface of what makes this place truly extraordinary. This isn't just a deep hole in the ocean floor, it's a portal to an alien dimension that exists right here on Earth, where the fundamental rules of survival are completely rewritten. Before we descend into this otherworldly realm, I want to hear from you. Comment below and tell me where you're watching from and how the weather is treating you today. It's humbling to realize that no matter how comfortable your current environment is, just a few miles beneath the nearest ocean surface, conditions exist that would instantly crush any unprotected human being. Here's what makes this journey so compelling. We're not speculating about distant planets or theoretical environments. The Mariana Trench represents the most extreme conditions that actually exist on our home planet, and what we've discovered there is forcing scientists to completely reconsider what's possible for life in the universe. The first aspect that transforms this trench into an alien world is the crushing weight of water above it. At sea level, atmospheric pressure measures approximately 14.7 pounds per square inch. But as you descend toward the deepest sections of the trench, specifically Challenger Deep, the water pressure increases relentlessly with every meter. By the time you reach the bottom, over 7 miles down, the pressure has increased to more than 1,100 times what we experience at Earth's surface. To put this in perspective, it's equivalent to having 50 jumbo jets stacked on top of every square inch of your body simultaneously. This crushing force would instantly compress any ordinary submarine into a metal pellet smaller than a marble. The engineering required to survive such conditions pushes the boundaries of human technology. Only the most advanced submersibles, constructed with titanium spheres and specialized synthetic materials, can withstand this immense pressure without being crushed like an empty soda can. Even these sophisticated vessels groan and creak under the strain as they descend, their hulls compressed by forces that would pulverize steel. What makes this pressure even more remarkable is how it affects the basic properties of matter. Water itself behaves differently under such extreme compression, becoming denser and altering its chemical properties. Materials that are solid at the surface can become fluid, while gases are compressed into states that don't exist anywhere else on our planet's surface. The second alienating factor is the absolute absence of light. As you descend through the ocean, sunlight fades rapidly. By 200 meters deep, the familiar blue glow of daylight has completely disappeared. By 1,000 meters, you've entered a realm of total darkness that has remained unchanged for millions of years. This darkness isn't simply the absence of illumination. It's an ancient, primordial blackness that predates human civilization. No natural light has ever penetrated to the trench's deepest sections. The only illumination comes from the eerie, ghostly glow of bioluminescent creatures that have evolved their own biological lighting systems. In this perpetual night, vision becomes nearly useless. Creatures that call this place home have developed entirely different sensory systems, relying on vibration detection, chemical sensing, and electrical field perception to navigate their world. It's a reminder that our human experience of reality, so dependent on sight, represents just one narrow slice of how life can perceive and interact with the environment. What topic in deep ocean exploration puzzles you the most? Share your thoughts in the comments below and I'll research it for a future episode. Your curiosity drives the content on ancient underwater mysteries. Temperature represents another factor that makes the trench profoundly alien. Near the surface, ocean temperatures vary with climate and season. But in the trench depths, temperatures hover consistently just above freezing, typically between 1 and 4 degrees Celsius. However, this cold environment contains shocking temperature contrasts. Along the trench slopes and floor, hydrothermal vents burst forth with superheated water reaching temperatures above 300 degrees Celsius. These vents create stark thermal boundaries where freezing cold water exists just meters away from conditions hot enough to melt lead. These extreme temperature variations create microenvironments that can support life in one location while remaining completely lethal just a short distance away. It's like having Arctic and volcanic conditions existing side by side in the same ecosystem, creating opportunities for life forms that have adapted to exploit these dramatic contrasts. The chemical composition of the trench environment adds another layer of alienation. While surface ocean water contains dissolved oxygen that supports familiar marine life, many regions of the trench are oxygen-depleted or completely oxygen-free zones. This oxygen scarcity forces life to develop entirely different metabolic processes. Instead of relying on oxygen for energy production, organisms in these zones have evolved chemosynthetic systems that derive energy from chemical reactions involving sulfur compounds, methane, and other materials that would be toxic to surface-dwelling creatures. Near the hydrothermal vents, the water becomes a chemical soup rich in minerals dissolved from deep within Earth's crust. These solutions contain heavy metals, sulfur compounds, and rare earth elements in concentrations that create environments more similar to theoretical alien worlds than anything else on Earth's surface. Nutrient availability in the trench follows patterns completely different from surface ecosystems. Instead of relying on photosynthesis and the ocean's productive surface layers, the trench ecosystem depends on a constant gentle rain of organic debris called marine snow. This marine snow consists of tiny fragments of dead plankton, organic particles, and mineral deposits that drift down from the surface layers over days, weeks, or months. Every particle becomes precious in an environment where energy sources are scarce, creating a food web built entirely around scarcity and efficient recycling. The geological activity in the trench adds dynamic instability that makes it even more alien. The trench sits along an active subduction zone where massive tectonic plates slowly grind against each other. This constant geological tension produces regular earthquakes, underwater landslides, and sudden changes in the seafloor topography. The sound environment of the trench is equally otherworldly. While sound travels faster and farther in water than in air, the deep trench often feels eerily quiet. However, this silence is occasionally broken by the distant rumbling of tectonic activity, the groaning of shifting crustal plates, and mysterious sounds that scientists are still trying to identify and understand. Like what you're learning about our planet's most extreme environment? Hit that subscribe button and turn on notifications. Your support means everything to ancient underwater mysteries as we continue exploring these incredible hidden worlds. Don't forget to like this video and share it with anyone who appreciates the extraordinary mysteries that exist right here on our own planet. Despite these seemingly impossible conditions, life has found ways not just to survive, but to thrive in the trench environment. The organisms that call this place home have evolved biological solutions so creative and efficient that they're inspiring new biotechnologies and challenging our understanding of life's limits. These creatures possess cellular mechanisms that can function under crushing pressure, specialized proteins that remain stable at extreme temperatures, and metabolic pathways that can extract energy from chemical sources that would poison most life forms. They represent living proof that life's adaptability extends far beyond what we once thought possible. The isolation of the trench environment has allowed evolution to proceed along completely different paths. Many species found in the deepest sections exist nowhere else on Earth, having been separated from surface ecosystems for millions of years. This isolation has created evolutionary laboratories where life has experimented with forms and functions that seem almost impossible. The trench's extreme conditions provide insights that extend far beyond marine biology. Scientists studying these environments are gaining crucial understanding about the potential for life on other worlds, particularly in the subsurface oceans of icy moons like Europa and Enceladus. If life can adapt to the crushing pressures, chemical extremes, and energy scarcity of the Mariana Trench, it suggests that similar conditions elsewhere in the solar system might also support living organisms. The trench serves as our closest analog to the alien environments we might encounter as we explore deeper into space. The technological challenges of exploring the trench are pushing the boundaries of human engineering. Every successful mission to these depths represents a triumph over conditions that would instantly destroy conventional equipment. The innovations developed for trench exploration are finding applications in other extreme environments, from deep space missions to Arctic research. Understanding the trench environment also provides insights into Earth's geological processes. The extreme conditions here offer windows into the forces that shape our planet's crust, drive continental drift, and influence global climate patterns through deep ocean circulation. What aspects of this alien world fascinate you most? Is it the crushing pressures, the absolute darkness, or perhaps the temperature extremes? Comment below and let me know which element of the Mariana Trench's environment you find most mind-boggling. The Mariana Trench represents more than just an extreme environment. It's a reminder that our planet still holds mysteries that rival anything science fiction has imagined. In an age when we can map distant galaxies and probe the structure of atoms, this deep ocean realm remains largely unknown and continues to surprise us with each new discovery. The trench challenges us to expand our definitions of habitability and life itself. It demonstrates that the boundaries between possible and impossible are far more flexible than we once believed. Here, in conditions that seem designed to exclude life, we find ecosystems as complex and diverse as any on Earth's surface. As we continue to explore and understand this alien world beneath our oceans, we're not just satisfying scientific curiosity. We're preparing for the greater exploration of truly alien environments that await us elsewhere in the universe. The Mariana Trench serves as our training ground for encountering the unknown, teaching us that life's possibilities extend far beyond our current understanding. Every descent into its depths brings us closer to answering fundamental questions about life's resilience, the limits of biological adaptation, and the potential for discovering life in the most unexpected places. The trench reminds us that the most alien world we've ever encountered isn't millions of miles away. It's right here beneath our feet, waiting to reveal its secrets to those bold enough to venture into its crushing darkness.